This is the second part of the electricity unit. This part is going to discuss voltage, resistance, and electrochemical cells. So if we think back to our analogy using the racetrack was the circuit, and the cars that were going around the racetrack would be considered the current. So if you were thinking about this in terms of, okay, here's a little play racetrack set, and you have some Matchbox cars that are on there, would the Matchbox cars move anywhere by themselves? No, they wouldn't. So how would you make them go? Well, with your hand, you'd have to add some force. Well, voltage is like that force that you'd add to get the cars going around the track. Voltage is what's going to be pushing your charges around the circuit. So the difference in electrical potential potential energy between two places is called voltage, or potential difference. The unit of measure of voltage is actually the volt, or a capital V. Okay, voltage causes a current in an electric circuit. Okay, it's what's pushing your charges through the circuit. So you can think of voltage as the amount of force pushing an electric current. Now, an electric circuit also requires a source of energy, such as a battery, to maintain a voltage. Okay. A voltage source is a device that creates a potential difference in an electric circuit. So batteries and generators are good examples of voltage sources. Okay, a voltage source has two terminals. Okay, the voltage between the terminals causes your charges to move around the circuit. Okay, so let's draw a little battery over to the side. You can draw it with a little button on one side. Okay, the button side is the positive end. The flat side of your battery is your negative terminal. Okay, so you have electrons that are in your current or in your circuit already. Okay, so these electrons are already in your circuit on that wire. And once you add a voltage source, like a battery, and you hook those up to your energy source, then these electrons, which already have a negative charge, they want to get away from this negative end of the terminal. So like charges want to repel each other. So it's going to push your electrons away. And where will your electrons want to go? Well, they're going to want to go over here to this positive side of the battery because opposites attract. So it's going to go towards the positive terminal. So because of this potential difference between your two terminals of your voltage source, that's what's going to create your voltage, which pushes your electrons from the negative to the positive. Okay, so we know that they're traveling negative to positive. Okay, another factor in circuits is resistance. We know that current depends on resistance. Okay, the amount of current that exists in a circuit depends on more than just voltage. Current also depends on the resistance of the materials. Okay, resistance is a measure of how difficult it is for charges to flow through the material. The greater the resistance, the less current there is for a given voltage. So the unit of measure of resistance, okay, so which unit do you use for resistance? Well, it's called the ohm. Okay, and it's represented by the Greek symbol, the omega. That's going to represent ohm. What are some factors then that determine resistance? Okay, well, your material can determine resistance, like insulators. They have a high resistance because it is difficult for the charges to move. Okay, and conductors have a low resistance because charges can move through them easily. Length is also a factor that determines resistance. We know that long wires have more resistance than short wires. Because through a long wire, there's going to be more of the opportunity for the electrons to be bumping into other atoms and other electrons that are already existing. The diameter of the wires also can affect it. So the narrow wires have less electric current flowing through than wider wires. Okay, therefore, the smaller the diameter of the wire, then the more resistance. And the more resistance. So similarly, thin wires have more resistance than thicker wires. So think about drinking a milkshake with a narrow straw versus a wider straw. Which one's going to be easier for you to drink the milkshake? Well, the wider one's going to be easier. You're going to be able to get more milkshake through that straw than with a narrow straw. The same thing is happening with your electric current through a narrow versus a wide wire. So the more narrow the wire, the less space it has, the more constricting it is, and the better chance that your electrons are going to be running into something else, causing greater resistance than if they have more space with a wider diameter of a wire. Okay, temperature is another factor. Okay, so the electrical resistance of most materials increases as the temperature increases. And as the temperature decreases of most materials, the resistance decreases as well. So that's a direct relationship. Okay. Moving on to another part that affects your circuit is electrochemical cells. So you're going to think of battery when you think of this, and it's not quite what you think of. So an electrochemical cell is a device that transforms chemical energy into electrical energy. Okay. An electrochemical cell consists of two different metals called electrodes, which are immersed in a substance called an electrolyte. Okay. An electrolyte is a substance that conducts electric current. So think about Gatorade. Gatorade has electrolytes. You know, Gatorade's a liquid. Well, the electrolyte is the liquid part. Okay. So what happens? The electrolytes are a copper sulfate and a zinc sulfate, which is separated by a barrier and mixed with water. The electrodes then, that's the metal pieces, they're made out of copper and zinc. The part of the electrode that's above the surface of the electrolyte is called a terminal, which we've used that term before, a terminal. The terminals are used to connect the cell to a circuit. Okay, so how does a battery work? You're having chemical reactions that occur between the electrode and the electrolyte in an electrochemical cell. These reactions cause one electrode to become negatively charged and the other electrode to become positively charged. Because these electrodes will have opposite charges, there is a voltage between them. Okay, so that is what your potential difference is, your voltage. Because one's negative and one's positive. Do you see the difference? Okay. And the voltage, we know, causes charges to flow. Now, if the terminals are connected by a wire, then charge will flow from one terminal to the other. Well, what is considered to be a real battery? So several electrochemical cells that are stacked together actually form a battery. Today, what you think of when you see a AA or AAA battery, you call that a battery, but those are actually single cells. And that's what you call batteries. But a real battery, you have to have two or more electrochemical cells that are connected in a series. So this means that the positive terminal of one cell is connected to the negative terminal of the next. So like how you would add new batteries to a flashlight, and you open up the end of the flashlight and you put those in one on top of the other where you have positive to negative. The terminals are all connected and they're in a series, stacked. That's actually how they're stacked. That would be considered the battery. And it's made up of those single cells. Okay, there's also two different types of electrochemical cells, wet cells and dry cells, which are easy to remember because a wet cell is an electrochemical cells in which the electrolyte is a liquid. Like car batteries use sulfuric acid as the electrolyte. Okay, so here's your wet cell example, which looks more like a car battery. And then your dry cell, which you probably use on a more regular basis, like a AA or a AAA, that's a dry cell battery. It's because the electrolyte, it's a paste. Okay, so this concludes the second part. Our third part is going to talk more about Ohm's law, features of a circuit, and series and parallel circuits. Thank you for listening.